In the last class of ray optics, we have read what is reflection, what is mirror, types of spherical mirror, image formation in spherical mirrors. Then we read about magnification and laws of reflection. In this class, we will study what is refraction. And the topics we will study in this classes are refraction, its laws. Then next is refractive index, rectangular glass slab, then prism, lenses, lens formula, final convention, these are the topics we will cover in this class. Mainly we will focus on these 5 topics. First is refraction, laws, refractive index, rectangular glass slab, and prism. First, we will understand what is refraction. We will understand by with the help of a diagram. This is normal. We will represent L and N dash. This is incident ray. Then, if this is the incident ray, how the light will reflect back? Will reflect back in this manner. As we have read, reflection is the phenomenon in which light bounces back in the same medium. This is reflection. This is angle I, angle R. But in refraction, light will not bounce back. It will pass from one transparent medium to another transparent medium. Let's say this is medium 1 and this is medium 2. Then the light will pass from medium 1 to medium 2. This is called refraction, in which the refraction is the process in which light travels from one transparent medium to another transparent medium. We denote this as R dash. And this ray which comes out after the process of refraction is called refractive index. Next, what is refractive index? Before going to refractive index, first we will know the laws of refraction. In laws of reflection, we read 2 laws. In the laws of refraction also we will read 2 laws. First law is the incident ray, refracted ray, normal at the point of interface lie on same plane. This is normal. This is incident ray. This is refracted ray. What this law says? This law states that incident ray, refracted ray, normal at the point of interface. This is the point of interface or the point of contact. These all lie in same single plane. This is that plane in which these 3 lines lie. This we denote as angle I. This is angle R. This is first law of refraction. Let's write it. Incident ray, refracted ray, normal at the point of interface. Point of interface all lie on same plane. Okay, this is first law of refraction. What this says, incident ray, refracted ray, normal at the point of incidence all lie on same plane. Second law is very important law, and mostly numericals come based on second law of refraction. This is normal, angle I, angle R. Okay, this is a diagram of refraction. What second law says, the product of refractive index and the sine angle of incidence or sine angle of refraction. Then we should know what is refractive index. Further we will know what is refractive index, but first we will know what is this law. This law says that the product of refractive index and sine angle of incidence or angle of refraction is constant. Let's say this is medium 1. Medium 1's refractive index is mu. This is medium 2's refractive. This is medium 2. So the refractive index is mu 2, or we can write mu 1 or mu 2. We denote refractive index by letter mu or n. So according to this law, mu 1 sin I equal to mu 2 sin R. Means according to this law, the product of refractive index and the sine angle of incidence or sine angle of refraction is constant, or you can write like this: mu 1 into sin I equal to constant, and mu 2 into sin R equal to constant. As these both are constant, so we can write as mu 1 sin I equal to mu 2 sin R. If we will write mu 2 by mu 1, we will bring mu 1 to this side and mu R to this side, then it will be sin I by sin R, which is constant. This is second law of refraction, or we also say it as Snell's law. Second law of refraction is also called as Snell's law. What this says, the product of refractive index and the sine angle of incidence or angle of refraction is constant, and the formula for it is mu 2 by mu 1 equal to sin A by sin R equal to constant. So these are the two laws of refraction. Next, there are two basic difference between reflection and refraction. So, difference between reflection and refraction. First, reflection needs one single medium. Reflection needs only one medium, but refraction needs two medium. This is the first difference between reflection and refraction. Two mediums. And second difference between is this is normal, this is incident ray. What reflection says? When the light rays passes from one medium to another medium, changing its direction, it will pass through the medium. But reflection, the light bounces back. This is another difference between, or we can say this is the second difference between reflection and refraction. And there is a fact that we can say, let's say this is water medium, or we will say this is a glass medium. This is air and this is glass. This is normal. When some rays of light incident on glass, then some rays reflect back and some rays refract. Means we can say that reflection and refraction both can occur at a same time. So for a single medium we can say reflection and refraction both. Next topic is so first we will know what is refractive index. Okay, what is refractive index? The ratio of speed of light in air or vacuum medium to the speed of light in the medium is called refractive index with respect to that medium. For example, this medium is air and this is glass. How we can find out the refractive index of glass? The formula is speed of light in air or vacuum by speed of light in glass medium. We denote refractive index as mu. The formula for mu is C by V. What is C? Speed of light in air or vacuum. Speed of light in air, vacuum. What is V? V is speed of light in medium. Speed of light in any transparent medium we can say. So this is the general formula of refraction, that is mu equal to C by V. C is speed of light in air or vacuum medium and V is speed of light in any transparent medium. And the value of C is 3 into 10 to the power 8 meter per second, which you all have to remember this formula, this value of C, because in questions when numerical will come, it will ask the value of mu or the value of V. This never asks in question. For example, in a question mu is given as 1 and you know the speed of light in air, then you have to find the speed of light, means of any transparent medium, that is V. What is the formula for that? If mu equal to C by V, by cross multiplication we can write as V equal to C by mu. This is the formula. Means two types of questions come: to find mu, that is mu equal to C by V, or to find V, that is V equal to C by mu. Next, some refractive indexes of common materials are given. We will make a table. Material refractive index. First, here is 1.0003, that is equivalent to 1. The refractive index of air medium is 1.003, but you can write it as 1. Next, ice, it is 1.31. Then water. Refractive index of water and refractive index of ice is very close, as refractive of ice is 1.31 and refractive index of water is 1.33. Next is glass crown. Glass crown refractive index is 1.52. And the last one is diamond. .42. Mainly questions come on these materials only: air, ice, water, glass and diamond. So these are some common refractive index of materials which is given. Next is next one is solve a numerical question. Given speed of flight in glass equal to 2 into 10 to the power 8 meter per second. In the question it is given speed of light in glass 2 into 10 to the power 8 meter per second. Means we have given the value of B. What we have to find? A refractive index or value of mu. Implies that B equal to 2 into 10 to the power 8 meter per second. We have to find mu. According to formula, mu equal to C by V equal to C, value of C is 3 into 10 to the power 8 meter per second. 3 into 10 to the power 8 meter per second by 2 into 10 to the power 8 meter per second. This will be cancelled. The result will be 1.5. So the refractive index of glass is 1.5. We will solve another numerical. Even it is also same as the last one. Speed of light in a medium it is given. Last time it was given that the medium was glass, but this time the medium is not given. It is given that speed of light in a medium and not given the name of the medium. We can take randomly any medium. So speed of light in the medium it is given as 2.5 into 10 to the power 8 meter per second. We have to find refractive index by using the formula. Implies that B equal to 2.5 into 10 to the power 8 meter per second. To find mu, according to formula, mu equal to C by V. Value of C is 3 into 10 to the power 8 meter per second divided by 2.5 into 10 to the power 8 meter per second. Cancelled. 3 by 2.5 equal to 30 by 25 equal to 6 by 5 equal to 1.2. So this is the refractive index of the given medium. As the given in the question was speed of light in the medium, which is 2.5 into 10 to the power 8 meter per second. to find refractive index, that is mu. According to formula, mu equal to c by v. We put the value of c, which is 3 into 10 to the power 8 meter per second, and the given value of v, that is 2.5 into 10 to the power 8 meter per second. We get the result as 1.2. Means we can write, implies that mu equal to 1.2. Next, okay, this is another type of question related to refractive index. The refractive index of a metal is given, and we have to find the speed of the light in medium. Given mu equal to 1.5. To find v, according to formula, mu equal to c by v and v equal to c by mu. Now we'll put the value of c and mu. As we know, the value of c is 3 into 10 to the power 8 meter per second, and value of mu is 1.5. So we'll write the speed of light is in the medium, which is the value of v, 2 into 10 to the power 8 meter per second. So got the result as 2.8 meter per second. Implies that v equal to 2 into 10 to the power 8 meter per second. In the first question, the speed of light was given 2.8 meter, 2 into 10 to the power 8 meter per second. We got the value of mu as 1.5. In this third question, the value of mu was given 1.5, and we got the value of speed in the medium is 2 into 10 to the power 8 meter per second. Next we'll proceed to a rectangular glass slab. Rectangular glass slab. This is one of the most important topic of this chapter, refraction through rectangular glass slab. We have seen refraction through water medium, glass medium. This is an example of glass medium, in which we will see how light refracts through a rectangular glass slab. We will draw the diagram and understand it. Let's say this is the incident ray, this is the rectangular glass slab, and this is air medium. This is glass medium, and this is again air medium. Means we'll see 2 times refraction will occur. From first time air to glass, from second time glass to air. Another thing, there is a cause of refraction. We'll say, first we'll read that thing, then we'll proceed to rectangular glass slab. If this is a medium 1, medium 2, if refractive index of 1 is greater than mu 2, then medium 1 is called optically denser medium, which has more density, that is called optically denser medium. And the medium whose refractive index is less, that is called optically rarer medium. Optically denser and optically rarer. In this case, when ray of light moves from denser medium to rarer medium, then it will bend away from normal. the ray of incident came and it will bend away from normal. Means this is normal, the angle of refraction will be more. In which case, when the refraction occurs from denser medium to rarer medium, this will be the value of angle of refraction is more. In the second case, when this is medium 1, this is medium 2, when mu1 is less than mu2, then medium 1 is optically rarer medium and mu2 is optically denser medium. Then when light travels from optically rarer medium to optically denser medium, then it will bend towards normal. It will bend in this way and the angle of refraction will be less. So these are the two cases of refraction. If light travels from optically rarer medium to optically denser medium, then it will bend towards normal, and if light travels from optically denser medium to optically rarer medium, then it will bend away from normal. Then we will proceed to rectangular glass slab. This is a rectangular glass slab. This is air medium, this is glass medium, and this is again air medium. In this case, refraction will occur two times. First from air medium to glass medium, then again from glass medium to air medium. This is incident ray. This is the normal n dash. This is angle of incidence. As air medium is rarer medium and glass medium is denser medium, then the light will bend towards normal. This is R. This we can say I1, R1. If you will say, we will see the nature of light. We read in the first live class that nature of light is light travels in a straight direction. If light will travel in straight direction, then it will seem to pass through this line, and the angle formed between the apparent path and the actual path is called the angle of deviation. We denote it as sigma. This is the angle between apparent refracted ray and the actual refracted ray. This is called angle of deviation, that is sigma. I1 is angle of incidence 1. Incidence 1. R1 is angle of refraction 1. So this is I1, this is R1, and this is sigma. What is sigma? It is the angle of deviation. Then again, first refraction occurred, that is from glass medium to air medium to glass medium. Now second refraction will occur, that is from glass medium to air medium. So this is the incident ray for the second refraction. We will draw the normal M dash, and here the refraction will be from glass medium to air medium, that is denser medium to rarer medium. So refraction will be away from normal. This is R2, this is I2. So this is basically refraction through rectangular glass slab. In glass slab, basically refraction occurs two times. First time it is air medium to glass medium, second time glass medium to air medium. I2, angle of incidence to R2 angle of refraction 2. So this is basically the angle, refraction through rectangular glass slab. Again we'll overlook to this. First, this is the incident ray that travels from air medium to the glass medium. This is first refraction. When the light travels from rarer medium to denser medium, or optically rarer medium to optically denser medium, then it will bend towards normal. So I1 became the angle of incidence 1 and I2 is the angle of refraction 1. Then the angle formed between the actual ray and the actual refracted ray and the apparent refracted ray is called angle of deviation, that is denoted by. Then next, the refracted ray for first refraction, the incident ray for the second refraction. So this refracted ray which occurred in the first refraction, this will become the incident ray for the second refraction. So again we draw a normal M and M dash, and this time the refraction will be from glass medium to air medium. So as the light traveling from optically denser medium to optically rarer medium, so light will bend away from normal, and I2 is the angle of incidence 2 and R2 is the angle of refraction 2. So this is basically refraction through glass slab. Next is prism. What is prism? Prism also, it is made of glass, and the medium inside it is a glass medium. Here also again we will see refraction 2 times, from air medium to glass medium, and again from glass medium to air medium. Let's say this is incident ray. This is the apparent refracted ray and this is the refracted ray. This is angle of incidence. This is N and N dash, which is normal. This is refracted ray. For fast refraction, this is air medium, this is glass medium. Means refraction occurs from optically rarer medium to optically denser medium. Then light will bend towards normal. So here light ray had bended towards the normal, and in the second refraction, the refraction will be from glass medium to air medium, that is from optically denser medium to optically rarer medium. Then the light will bend away from normal. Another normal, that is M and M dash. This is the emergent ray, or we can say in this way the light has refracted again. Means from air medium it go inside the glass medium. This is first refraction. Then in second refraction from glass medium to air medium. This is the concept of prism. This is angle of deviation, sigma. So next, by prism experiment we can get 7 colors, that is Vivgure. If we are putting a white light, we are directly incidenting and white light to prism, then it will give 7 colors. One, two, three, 4, 5, 6. Okay. If we incident and white light directly to the prism, it will give 7 colors. The colors are like this: VIB, GYO, another ray of light, R. These are the 7 colors. Vividor. V stands for violet, I stands for indigo, blue stands for blue, B stands for blue, G for green, Y for yellow, O for orange, and R for red. So during refraction through prism, white light spreads into 5 different colors, sorry, 7 different lights, in which the red color light has the highest wavelength and the violet color light has the least wavelength. If we put another prism vertically inverted to it, a prism of same size, if we put vertically inward to it, then again refraction will occur. These 7 lights will give back the white light again. So this is refraction, second refraction. In the first prism, this is, we can say P1, P2. First prism, white light spread into Vividor. Second refraction or second prism, the Vividor colors spread out into again white color. So giving arrow mark is mandatory for all. So this is refraction through prism. Next, what is lens? A transparent optical device with at least one curved surface which refracts light is called lens. Again I am repeating, a transparent optical device which has at least one curved refracting surface is called lens. There are 2 types of lens basically we will study. Concave lens, convex lens. In the last class we read about concave mirror and convex mirror. In this class we will read about convex lens and concave lens. So in reflection part, we came across some terms related to mirror. In this refraction part, we will come across some terms that is related to refraction or spherical lenses, that is convex lens and concave lenses. First is optical center, denoted as O. This is center point of lens. Optical center, this is center point of lens. Next is principal axis. Line through optical center and center of curvature passes. Line through optical center, that is I am writing as O. Line through optical center and center of curvature. Next is focus, denoted as F. Point where parallel rays converge or diverge. Converge or diverge. As last class we have studied two types of rays, convergent ray and divergent rays, and so focus does that, the point where the parallel rays or converge or diverge rays. Next is radius of curvature. Radius of curvature. This is the radius of the sphere of which length is a part. Radius of the sphere of which length is a part. So these are the some key terms related to spherical lenses, that is concave lens and convex lenses. First, I will draw some diagram related to concave and convex lenses. First is concave lens. Normally, the diagram of convex lens is concave lens is like this. Two concave mirrors together are called concave lens. So this is the diagram of concave lens. Then there are some types of concave lens also. The types of concave lens are, first is double concave lens. This normal diagram of concave lens is called double concave lens, which uses two concave mirror to form. This is double concave lens. This is the first type of concave lens. Second one is plano concave lens. Plano concave lens uses one concave mirror and another plane mirror. So this is called plano concave lens. So this is the general diagram of plano concave lens, which uses one plane mirror and another concave mirror. And the third and the last type of concave lens is convexo concave lens. Convex or concave lens. This is the general diagram of convex or concave lens, which uses one concave mirror and another convex mirror to form. So we have completed concave lenses. Then we will proceed to convex lens. Convex lens. The general diagram of convex lens is like this. This is the general diagram of convex lens. Now, convex lens are also of three types. First is double convex lens. This is the first diagram I have made. This is only the example of double convex lens, in which the lens use two convex lens to form. Next one is plano convex lens. What is plano convex lens? This is the example of plano convex lens, in which it uses one convex lens and another plane mirror. The third type is concave convex lens. This is the example of concave convex lens, in which the mirror uses one concave mirror and another convex mirror to form it. So these are the types of concave and convex lenses. Next is image formation in convex mirror. As in refraction part, concave mirror was very important, as most of the refractions occurs in concave mirror, and there are 4 cases of reflection in concave mirror and only 2 cases of reflection in convex mirror. But in lens part it is just opposite. Convex lens is very important than concave lens, as more cases of refraction occurs in convex lens than in concave lenses. So generally in this class we will come to know the image formation by lenses of convex lens. Image formation by convex lens. We'll make a table and try to understand it. Object position. Next is image position. Next is nature. Last one is size. By this table we can know the image formations in convex lenses. First is when object is placed beyond 2f. 2f means 2 into focal length. Beyond 2f, then the image formation will be between f and 2f. F and 2f. The nature of the lens will be image will be real and inverted. Inverted, and the size will be diminished. The next is when the object is placed at 2f. When the object is placed at 2f, then the image will be same at 2f. The nature will be real and inverted, and again the size will be of the same size, as the object position and image position is same, so the nature of the size will be same. Third case, when the object is placed between f and 2f, f and 2f, then the image will be beyond 2f. This is just vice versa of first one, real and inverted, and the size will be magnified. Means the size of image will be much more than size of object. In the last case, not last, it is the fourth case, that when the when the object is placed at f, then the image will be at infinity, real, inverted, highly magnified. Means the size of image is much more greater than the size of object. And the last case, when the object is placed between O and F, means between optical center and the focus, then the image formation will be the position of image will be same side, virtual and erect. This is the nature of the image. This is magnified. Size is magnified. So there are 5 cases of image formation in convex lenses, out of which the 4 cases beyond 2f, at 2f, between f and 2f, and at f. In these 4 cases, the nature of the image formation is real and inverted. But the exception case is when the object is placed between optical center and focus, then the nature of the image is virtual and erect. So this is the table for image formation in convex lenses. Next is lens formula. In this chapter, numericals mainly come from refractive index, lens formula, mirror formula, and magnification. As we have in the last class, we have completed the mirror formula and magnification, and in this class we have already completed the refractive index part. This is the last main important topic of this chapter, that is lens formula. Many numericals come based on this formula. It is as similar to mirror formula. As we know, the mirror formula is 1 by f equal to 1 by v plus 1 by u. Hence 1 by focal length equal to 1 by image distance plus 1 by object distance. Lens formula is 1 by f equal to 1 by v minus 1 by u. Means 1 by focal length equal to 1 by image distance minus 1 by object distance. Next, sign conventions. Okay. This is the diagram of concave lens. This is principal axis and this is pole. This is principal axis and this is pole. In the sign convention of concave mirror, we'll came across that focal length, optical center, radius of curvature, center of curvature lie in which sign? First, anything that lies right side of the pole is positive. Means this is, as we know, this is the pole, this dotted line that passes through the center is pole. Anything that lie right of this pole is positive, and anything that lie left of this pole is negative. For same as principal axis, anything that lies above the principal axis is positive, and anything that lie below the principal axis is negative. So sign convention is like this: positive, negative, positive, negative. This is positive, this is negative. Okay, this is the sign convention for concave mirror, sorry, concave lens. Next is for convex lens. This is the pole of convex lens. This is the principal axis of convex lens. The sign convention of convex lens also follows the sign convention of concave lens. That is, anything that lies right side to the convex lens, the pole of convex lens, that is positive, and anything that lies left to the pole of the convex lens, that is negative. And same for principal axis, anything that lies above the principal axis of the convex lens is positive, and anything that lie below the principal axis of convex lens, that is negative. So the sign convention is same as the sign convention of concave lens. This is positive, this is negative. Positive, negative. This is positive, this is negative. So this is sign convention of convex lens. Next, we have completed all the topics of this chapter. Now we will do some numericals based on lens formula. First question, given u is given, means object distance is given to us, that is 30 centimeter. Focal length f is 20 centimeter. By using lens formula, we have to find the v, means image distance. According to formula, 1 by f equal to 1 by v minus 1 by u. Then the formula says that 1 by v equal to 1 by f plus 1 by u. 1 by v equal to 1 by 20 plus 1 by 30. Implies that 1 by v equal to LCM is 60, 3 plus 2, implies that v equal to 60 by 5 equal to 12. So the image distance is 12 centimeter. As you get to know that given it was image distance, sorry, object distance is 30 centimeter, focal length is 20 centimeter. To find the value of v, that is image distance, by the lens formula, that is 1 by f equal to 1 by v minus 1 by u. By putting the formula, we get the result that v is 12 centimeter. Okay. Next question. Given d equal to, sorry, u equal to 15 centimeter, f equal to 10 centimeter. We have to find the magnification. As in the last class we studied what is magnification. The formula of magnification is m equal to minus v by u or hi by ho. But here height of the image and height of the object is not given, so we have to find the magnification by the formula minus v by u. So before that we have to find the value of v. For that we have to put the length formula, 1 by f equal to 1 by v minus 1 by u, implies that 1 by v equal to 1 by f plus 1 by u. 1 by v equal to 1 by 10 plus 1 by 15, implies that v equal to 3 plus 2 by 30, v equal to 30 by 5, which is 6 centimeter. This is the value of b. By putting the length formula, we got the image distance is 6 centimeter when the object distance was 15 and the focal length was 10 centimeter. Now we will find magnification. M equal to minus v by u, which is minus 6 by 15, equal to minus 2 by 5. This is the result, final result, magnification. So this is all for today. In this class we have completed all the parts, all the topics of refraction, that is refraction, laws of refraction, refraction through glass slab, refraction through prism, lenses, types of spherical lenses, image formation in spherical lenses, then sign conventions, and we have performed some numericals based on it. So this is the end of chapter ray optics and optical instrument. Thank you. Clarity on empty